Well, hello everyone, and welcome to the third meeting of the Turba online discussion group on the history of alchemy, broadly defined. This autumn, we are meeting roughly every other week on Fridays. We are running these meetings with the support of the Society of the History of Alchemy and Chemistry, and are broadcasting online via the Shack YouTube channel. Before I begin, some quick administrative matters. To the best extent possible, please keep your video on and the sound off. I will be taking questions either in the chat or virtually. I aim to keep the meetings to an hour and a half, less so if there are not a lot of questions. Now, let me introduce our speakers today. Matteo Martelli, Lucia Maini, and Marianna Marchini. Matteo Martelli is professor in the history of science at the University of Bologna, where he teaches history of ancient science and technology, along with history of ancient medicine. His research focuses on Greek, Roman, and Byzantine science, with particular attention to alchemy and medicine, pharmacology, and its reception in the Syro-Arabic tradition. His publications include the 4 books of Pseudo-Democritus of 2014 and Collecting Recipes, Byzantine and Jewish Pharmacology in Dialogue of 2017. He's also the PI of the Alchemist project and is currently working on a critical edition and translation of the alchemical books by Zosimos of Panopolis, as they're preserved in the Syriac tradition. Lucia Maini is associate professor at the University of Bologna since 2014. She carries her research in the field of structural determination using X-ray diffraction techniques on single crystal and on powders. Well, this sounds kind of Chinese to me, but for chemists, it'll sound very familiar, I'm sure. Marianna Marchini is a drug professor in the Department of Educational Studies, Giovanni Maria Bertin, and research fellow in Giacomo Ciamician, Department of Chemistry at the University of Bologna. So first I will give the floor to Matteo Martelli. Matteo, if you would like to begin, please.
Yeah. I'm going to share the screen. Okay. Can you see the presentation?
Yes, yes, very well.
Thank you very much, Joe, for the introduction, and thank you very much for inviting us to this series of meetings of lectures on the history of on the history of alchemy. And today, the topic of our joint paper is the ancient chemistry, or the ancient chemistry, since we are talking about an earlier phase of alchemy and of Mercury. And this investigation was born, let's say, in the framework of the URC project Alchemist, or Alchemy in the Making, from ancient Babylonian, the Greco-Roman Egypt into the Byzantine, Syriac, and Arabic traditions. This is the full title of the project. And just a quick look, I would like just to give you a very quick look, theories, and to understand how the properties of substances were described and conceptualized in ancient texts. For instance, we will see some elements that somehow are prior the Mercury sulfur, the famous Mercury sulfur theory. In terms of sources, we will focus especially on, let's say, the earliest alchemical sources, so the Leiden and Stockholm papyri, Pseudo-Democritus, Zosimos of Panopolis. But what I think is interesting is that basically many of these technologies are already described in earlier texts that are not properly alchemical, like the work by Theophrastus, or the work by the pupil of Aristotle, or the works of physicians such as Dioscorides, or natural historian, if you want, like Pliny the Elder. And we will see how this technology was inherited in the Byzantine tradition and in the Syriac tradition. Somehow, through this investigation, we will, let's say, try to overturn a kind of a negative paradigm that was used to describe ancient alchemy. For instance, Holmyard, in this famous book on alchemy, writes that a closer examination of the Leiden and Stockholm papyri has shown that they could not yield any practical results. And it may therefore be that they were snippets collected by an alchemist. And I think the idea of alchemist here is not really, it's not a very good idea, if you want. And Holmyard identified late antique and Byzantine alchemy with an inverted pyramid of speculations and spiritual endeavors erected on a very small and fragile basis of genuine chemical operations. If you wanted, the project want to overturn these representations, since a textual and experimental study of ancient recipes allows to enlarge this chemical basis or the chemical operations at the basis of ancient theories and practices. But let's look at the topic of the paper today, so the extraction of mercury. For the sake of clarity, we decided to structure the paper into two different parts according to the two different technologies that were used to extract mercury from cinnabar, what we call cold extraction, and that basically uses grinding as the main procedure, and what we will call hot extraction, that is a sublimation technique. The cold extraction, the main sources for cold extraction are Theophrastus, so the natural philosophers that was a pupil of Aristotle, Pliny the Elder, and especially Zosimus of Panopolis, as his works is preserved in the Greek and in the Syriac traditions. I will read now very briefly some texts, some recipes that describe this cold extraction, and then I will give the floor to our colleagues, the chemists, to explain the chemical reality behind this text. The first and the earliest description of how mercury was extracted from cinnabar is actually to be found in the work on stones by Theophrastus, where we read liquid silver, so quicksilver, mercury, in Greek is argyros kytos, is produced when cinnabar is crushed with vinegar in a copper mortar and with a copper pestle. The same procedure is described by Pliny the Elder, more or less 3 centuries afterwards. And in this passage taken from the natural history, you can see that the passage is mainly, the procedures is mainly the same. Then we find the same technology described in an alchemical text by Zosimus of Panopolis in the 3rd, 4th century CE, in one of his chapters to Eusebia, where he writes, I think that it's better to pound cinnabar. In fact, different substances produce mercury when they are processed with water or vinegar in the sun. And we know this from experience, and every book and Chymistry and Maria say or claim lead mortar and lead pestle. Pound the cinnabar and with vinegar in the sun until mercury is nephele in Greek, so the cloud is formed. They do the same with tin. I think I would like to highlight a couple of details in this text. First of all, 2 very important alchemists are quoted. Chymistry is one of the earliest alchemists in the history of the Greco-Egyptian discipline, and Maria, the Jewish. Both are claimed, Zosimus claims that we're using metallic mortars and pestles to grind cinnabar. The metal is not copper, like in the case of Theophrastus, but is lead or tin, according to this source. Then another interesting description of these techniques is to be found in the Syriac tradition of the alchemical text, of the alchemical books by Zosimus, where we read in book 9, fully devoted to mercury, Another recipe, take copper powder and grind the cinnabar with water. Little by little, you will collect the mercury, again the cloud, that floats on the surface with a sponge until all this mercury disappears and dries up. Then put what is left in a vessel without a lid. You will cover it with another vessel and place this vessel on a fire of sawdust. You will find mercury in the upper vessel. I think this recipe is particularly interesting because here the metal, basically copper, is not introduced in the procedure as the metal of which the instruments were made, basically a copper pestle or a copper mortar, but the copper is introduced as an independent ingredient. And the second interesting part is that what is left basically is probably an alloy, an amalgam of mercury with the metal, is treated by fire in order to isolate mercury. And these two elements, as you will see in a moment, are two elements that any chemist today would basically recognize, even in the earliest recipes by Theophrastus, very quickly. But if we look at the history of ancient alchemy, basically 400 or maybe more, 500 years separate, let's say, the recipe by Theophrastus from this recipe by Pliny, Zosimus of Panopolis. Now I will leave the floor to Lucia Maini, who will better explain this technology.
Okay. Oh, great. So, just a second. Okay. So actually, what the mercury, the ancient sees is you see the ore, the mineral, and just it was transformed in the liquid mercury. But what we see, and that when we read the recipes with Matteo, we just in our eyes come out some formulas. And the formula was, we have the cinnabar on the starting, we have the mercury as a product, but we are missing a reactant. And if we carefully read the recipe, we highlight that we have copper, mortar and copper pestle, lead, tin, so we have metals. Also, after we have copper powder, as Matteo said, that they already recognize that the metal is playing a key role in the recipe, and we also have a vinegar. So what we did, we tried to do the replication by using synthetic cinnabar, so that is pure, that it will be easier also to recognize what happened. We used the copper, a powder of copper, okay. Copper, and our mortar actually is very cheap one, is based on ceramic. So we start grinding, and after 5 minutes, you already see that your powder is not anymore red, but it's getting dark. But you have to grind for a longer time, and with after 4 hours, adding vinegar in the meantime, you clearly see the presence of droplets of mercury. So this reaction worked, and actually this reaction was attracted a lot of attention also for the chemistry field, because it was cited by Laszlo Takacs, that is a chemist, metallurgist, and he reported the reaction of Theophrastus in this very scientific journal, the Journal of the Minerals, Metal and Materials Society. And just talking about as this reaction as the first mechanochemical reaction. Actually, mechanochemical reaction are a very important field nowadays. And Takacs would say just just say that the reaction probably just will product copper sulfide. So if it sounded reliable, plausible, but it really didn't give not a lot of information about the reaction. But since it has been cited a lot of time, and we just keep it, this is up to date, is 53 citation. It was 43 citation about 3 months ago, so it's quite used because it's nice to cite in all paper of mechanochemistry. But so it started to be the mercury, just the product could be mercury and probably copper sulfide, copper 2 sulfide, and then you really see the reaction that is written, what happens. But is it the real reaction? It sounds good for us, for all the chemists, sounds good, but it is a real one. Well, we can just characterize our product. What we use the X-ray powder diffraction. I don't want to teach you now what happens, but you clearly see that you have a pattern with peak, and these peaks are characteristic of my mineral, of cinnabar. But when we collected the diffractogram after grinding, you see that you have something totally different. You don't have to be an expert that they are not the same. And what this big bump is due to the liquid mercury, but the different peak position is due to the new phase. And with the help of a database, we are able to characterize this phase, to determine which is the phase present. And what we found is a metastable phase of chalcocite that you see from the formula that is different, it's not cobellite as reported before. What does it mean actually? Well, that means that no one really reproduced it. No one tried this reaction. The first witness about this reaction in the modern period is from Bailey's, is 1932, so it's not modern. For us it's not so modern, but sure for Matteo was very, very modern. And what they said that he did just grinding, the pieces of mercury just get silvery. So mean that you are starting to have the amalgam. But what we found out that is not the cobellite that is appear, but is chalcocite, and our characterization is really a standard technique. So I'm pretty sure that the people that were citing and talking about that were able to do this reaction. So just to highlight that sometimes it's not enough just to think that it can happen, but you really have to check what is happening in the reaction to understand what was happening outside the time. So now the second question for us was, is the liquid important? Do we need to have vinegar or water or nothing? And actually we tried with different liquid, water, vinegar, and acetic acid glacier, that is concentrated acetic acid. And vinegar actually is diluted acetic acid. So that is just diluted and concentrated, and without anything. And you can see that in all cases, the powder is black. You have, we can see that is the chalcocite, our copper sulfide, but with acetic acid glacier, you really see the drop of mercury, and the acid speed up our reaction. And what about the metals? So we tried to do the same reaction with tin, that is, sorry, I just leave the element, but this is tin, lead, and for tin, for example, what we observe is the formation of the tin sulfide, and you can see here you have some amalgam of mercury. It's clearly an amalgam because it looks like a chewing gum, So it's when you move it is not hard, it's soft, and we know that you can easily distill mercury from the amalgam by eating. So what was reported by Zosimus. With the lead, and we use it something that is used from the fishermen, and we obtain the lead sulfide. We didn't see the droplets of mercury, it was just a black powder, but probably what we obtained it was the amorphous amalgam that it was on the bottom, but it was not easy to identify. But for sure, if you heat it up, so heat it up at around 300 degrees, so it's not just with the sun, we say we need something more, but you can easily separate it. So at the end, also we tried why they do not talk about iron, because iron, it was a metal that was known and also could work. For our point of view, could be something that worked, but actually when we tried, it doesn't work. So they do not cite that, but there is no recipe about iron, and actually it doesn't work. So Matteo is again to you.
Thank you very much, Lucia. Yeah, and what Lucia was introducing basically already somehow help us to understand how we tried to use this data, the experimental data, to better understand and interpret and read ancient alchemical sources. And for instance, one point that we were basically thinking about is how these procedures and how the properties of these metals that were used to manipulate, to process cinnabar in order to have mercury were described in ancient alchemical text. And maybe it's not by chance that the ancient alchemists mentioned tin, copper, lead as metals that were used in the procedure, and they didn't mention iron because apparently it doesn't work. But what is also interesting is to notice how the ancients actually described these particular properties of metals to form amalgam with mercury. And this is a passage by Zosimus, where Zosimus first talks about cinnabar. He writes, when boiled with species, cinnabar does not lose its spirit. Indeed, fire makes its spirit, sorry, there is a typo, I mean its vapor, to run, but the vapor that flees away is captured by those bodies that are of its same nature and chase it, especially by tin. These bodies that are of the same nature of mercury and that are chasing it are the metals. And probably this idea is linked to the experimental practice of ancient alchemists who were used different metals in order to treat cinnabar and to extract mercury. And this idea that mercury has to do with the metals and may even represent one of his main constituents is clearly reported in another passage that is a quotation that Zosimus made of an earlier alchemist called Pebicius, where Zosimus writes, and this is in the Syriac tradition, on the fact that mercury comes from all the metallic bodies, since he believed that mercury is the unique substance that comes from all bodies. Pebicius stopped at the mark and shouted, all the metallic bodies are mercury. These are some elements that can anticipate the sulfur-mercury theory that was developed, especially during the Arabic period, the Islamic period. But let's now look at the hot extraction, where this idea that mercury can be as a spirit can be extracted from cinnabar becomes very, very clear. The main sources from the hot extraction are again our Pliny the Elder, Dioscorides, the Leiden Papyrus, and Pseudo-Democritus. But before starting reading these passages, I would like to read a passage by Vitruvius, where basically another technique, a very simple procedure was described in order to extract mercury by heating cinnabar. And he writes, during the digging, cinnabar sheds under the blows of tools tier after tier of mercury, which is at once gathered up by the diggers. When these clods have been collected, they are so full of moisture that they are thrown into an oven in the laboratory to dry. And the fumes that are sent up from them by the heat of the fire settle down on the floor of the oven and are found to be mercury. But these procedures can be very dangerous, since the people working in these laboratories were basically inhaling a lot of toxic fumes. And actually, the ancients were quite aware of the toxicity of mercury. These are different passages from Dioscorides, Pliny the Elder, and Zosimus that basically refer to or highlight the danger that to which basically the ancient alchemists could be exposed when they were treating and especially heating cinnabar. And Pliny even refers to the use of mask of bladder skin, in order to avoid inhaling the dust of cinnabar, which is highly pernicious, right? Pliny the Elder. And Zosimus of Panopolis basically highlights how mercury has a cold nature and kills those who drink it. And the philosopher, it is Democritus, claimed that those who have been affected by mercury is like a thirsty and drunk man. So maybe in order to avoid being exposed to these toxic fumes, the alchemists, or the ancients more in general, started to use a closed apparatus to sublime cinnabar. And this is an important source that we are the description of an important procedure that we already find in Dioscorides, where basically there is a technique to extract mercury from cinnabar by heating cinnabar. He writes, they put an iron shell containing the cinnabar in an earthenware casserole and enclose it with an ambix, that is a convex lid. And you can see in this ambix basically the root for the modern alembic. The ambix smeared on with clay. Then they light a fire upon the casserole with charcoal. They wipe off the vapor settled on the ambix, that is mercury. And basically this same technique that describes how to heat cinnabar in a closed equipment, in a closed, let's say, vessel, and how this cinnabar is put in this iron spoon, and is also reported by Pliny the Elder and by the Leiden papyrus. Now, along with similar, let's say, procedures, or by using a similar techniques, ancient alchemists try to boil cinnabar also with other substances, not only by putting it on this iron spoon. This is another interesting procedure that is described in a Byzantine text by Christianus, but is basically attributed to one of the father of ancient alchemy, so Democritus, Pseudo-Democritus. And this Byzantine alchemist writes, now this very famous philosopher, so Democritus, claimed, who does not know that cinnabar vapor is mercury, of which it is composed, so we have the idea of mercury as a main constituent of cinnabar. Therefore, if anyone grinds cinnabar with natron oil, mixes them together, puts them in the double bases, and lights a uniform fire underneath, he will catch all the vapor that was lying idle in the body of cinnabar. And this vapor is clearly the mercury that was extracted, according at least to this description from the mineral. And exactly the same procedure is also mentioned, reported in another Byzantine text that is anonymous, where we read, on cinnabar, you must know that the transformation of cinnabar happens by means of the natron oil. In this way, cinnabar is melted by a light fire. We have here an important information about the heating, as you know. And as you can see here, we don't have the use of any iron or any iron spoon, but instead we have this difficult and, as we will see, quite enigmatic ingredient, the natron oil, that is used to process cinnabar in order to obtain the liquid metal, so mercury. And now I leave the floor to Marianna Marchini that will explain us this kind of technologies.
Thank you, Matteo. So let's move on the replication in this particular type of extraction. From the sources that Matteo talked about, we can actually group all these procedure in three different, let's say, groups. The first one, simple heating of cinnabar. That was the description that Vitruvius gave us. The second one regard the heating of cinnabar in a closed vessel in presence of iron. And the third one, the last one that Matteo talked about, mild heating cinnabar, because we have light fire, in presence of the so-called natron oil. So let's just focus on a moment on the first procedure, simple heating of cinnabar. That is the, let's say, interpretation that the modern historians so far have given to all those sources. So this can we call roasting of a cinnabar. You can obtain mercury just heating up at high temperature, as you can see here, under a flux of oxygen, the cinnabar ore. But if we go on more detail reading, more let's say go to on detail on the reading of the sources, you can actually find some details that cannot be considered. Closed vessel, for example, and mild temperature are two variations in the procedure that were introduced and actually are not really in according with those with these reaction here that are claimed to be the one that they know. First of all, because if we have a closed vessel, we don't have the flux of oxygen and we don't have a reactant, so the extraction is not that efficient. The second point is mild temperature. To have these roasting, we have to heat up the system, and the mild temperature is not the perfect condition to have the extraction. But furthermore, what is important is when the procedure changes, also some new ingredients were added to cinnabar, an iron shell in one case, and this natron oil. So let's now go more in detail on the replication in order to see how reproducing those type of procedure can help us in understand if actually these reaction are working. The first one I want to talk about is the second procedure, so hot extraction of mercury from cinnabar in presence of iron. First of all, we have repeat the experiment with the iron powder that was added to a cinnabar inside our flask. Then we heat up the system with the Bunsen burner. I hope you can see the movie. And as you can see here, we have used this apparatus. Is a sort of distillation system where actually helped us to contain toxic fume that can come out, as you can see, while the reaction proceeds from the reaction. We keep heating the system with this Bunsen burner up to almost 10 minutes. After 10 minutes, we have stopped the reaction and we have taken a look on what was happening inside our flask. And as you can see, all the drops of mercury condense on the flask and even at the bottom of the bottom of the flask. So what we can say now is that actually the extraction is working. But then we move on to something that was more similar to the experimental condition that they could have experienced. So instead of using iron powder, we have substituted with the iron plate. We use a crucible with the lid on and then heat up the system for 10 minutes again. At the end, again, you can see all the mercury condensed on the lid that you can scratch and collect easily, as Dioscorides was saying. And then also the powder that you can see here in at the bottom of of the crucible can be analyzed in order to actually write and understand this reaction better. So from the XRPD analysis that already Lucia mentioned, those can give us some information. First of all, from the disappearance of these typical peaks that are referring to the cinnabar ore at the end of the reaction. So after eating, they are not present anymore, but different features appears. And those peaks are actually related to iron sulfide. That is the product of the reaction with actually also mercury that you have seen on the flask. So that is the reaction that is occurring inside the flask while we are eating. It's a known reaction you can find in literature and in books. And what is important to notice is that when they decided to actually use a closed vessel to avoid maybe the toxicity, to easily collect the mercury after the eating, actually they realized they need something else, in that case iron, in order to have efficient formation of mercury. Let's then move on to the last procedure we will talk about, that regard the use of natron oil inside this double vessel with light fire. So first of all, what is natron oil? Natron is a mineral that you can extract, and they were actually extracting in this Vadi El Natrun, this mining site, and is basically sodium carbonate decahydrate. So we are hypothesizing that they were referring to this mineral. For what regard oil, we think that maybe those natron was dispersed in a solvent. The solvent that they had available at the time were water, vinegar, or some vegetal oil. And those combinations were all tested in the extraction in order to understand if they have actually a role in this procedure. The first thing we have done in the lab is to actually observe if this sodium carbonate, so the natron, the mineral, has an effect in the extraction. We have performed the reaction under vacuum. Does it mean that we have removed the atmospheric oxygen inside our reaction flask in order to avoid the reaction of the mercury, the cinnabar, sorry, with the oxygen in the air, and we have added the sodium carbonate inside the vessel with cinnabar ore. We heat up with mild temperature in that case, which means we have not anymore our Bunsen burner, but we have a heating mantle, and we keep the temperature around 300, 350 degrees. We heat up, and after some times we can see again some drops of mercury condensed on the glassware. Exactly the same extraction without sodium carbonate. So keeping the vacuum inside the system, of course, is not working because we don't have the oxygen in the air. So in that case, with that procedure, we can actually see that the sodium carbonate has a pivotal, crucial role in the extraction of mercury in that condition. So closed vessel with mild heating. Then we have repeat again the extraction to something that was more similar again to what they could have experienced. So without removing the atmospheric oxygen, so it's perfect atmospheric condition, we heat up two different vessels. In one we have cinnabar ore and sodium carbonate. The other one we have exactly the same amount of cinnabar ore without sodium carbonate. Same time, same geometry of the system. At the end, what we observed, in one case where just cinnabar was heat up in presence of air, some residual cinnabar ore can be observed here because the oxygen inside the system, since it is a closed vessel, it's not enough to go to completeness of the reaction. In the case where also sodium carbonate was added inside the flask, we actually consume all the reagent and no more cinnabar could be detected with the XRPD analysis. So actually the reaction is working better in this condition. So again, mild heating and closed vessel. But what was intriguing for us is that this kind of reaction, so hot extraction of mercury with using this sodium carbonate was never reported in the literature. The only paper we were able to find was an old one, if we talk about chemistry, 1826, and but Mertier actually reported this reaction where cinnabar react with sodium carbonate, and as a product you could expect the formation of sodium sulfate that we were able to detect in our residual powder. And he also talked about sodium sulfide. Unfortunately, with the quantitative analysis, we were never able to detect even traces of this compound. So actually, we are not able yet to complete this reaction, but we know it's working. So we know the role of natron. Let's move on very quick to the solvent. We tested water, so we prepare a saturated solution of natron in water. We add to cinnabar, we heat up with a heating mantle, and at the end we observe that some drops of mercury appear, so the extraction occur, but is not that efficient as in the case with only dry natron. Why that? Because during heating, because the water evaporates quite heavily and quite quickly, we have sinter powder, so it's not really well mixed, the two type of the two powders we have in our crucible. And something similar was also observed with vinegar. As Lucia said, vinegar can be considered as an aqueous solution, a diluted aqueous solution of acetic acid, and also in that case the reaction occurs, but it's not as well working as in the case of just dry powder. But what it's important also to mention is that upon addition of a vinegar to a mixture of cinnabar ore and sodium carbonate, you can see bubbles coming from the crucible. It's an acid-base reaction. We are actually producing carbon dioxide, and actually that's something that perhaps we can say was recorded by a Byzantine alchemist who claimed that natron bubbles when it was placed in a liquid. So maybe that's something that would have happened. Finally, with oil, what happened? Again, we have used some vegetal oil, in particular flaxseed oil. Neither the two powder are soluble in this solvent, so we mix up the reaction mixture. We have heated up to our 350 degree. But what happened is under that condition, as you can see here, the oil burnt, so no formation of mercury where it was observed. And even if we lower a little bit the temperature in order not to burn the oil, no extraction occurred. So to conclude very quickly, what we have learned about natron oil using our replication. The natron, so the sodium carbonate work, it makes a difference in a closed vessel with mild temperature if you have it or not. But in the case of oil, what oil can be is still under debated. And just to mention another important point is the fact that we know that quicklime can work as a reactant, as a reductant actually in the extraction of mercury, and it is a white powder as sodium carbonate is. And they know actually they use it for other purpose, this quicklime that is basically calcium oxide. But we were never able to read about it in the sources we have analyzed. And maybe it's because natron has a particular role for the ancient, and I can let Matteo comment on that a little bit.
Thank you very much, Marianna. And we are at the end of our presentation. Just a couple of final remarks on this last point. We were basically wondering why natron oil was at some point introduced in this procedure. That was for a technical reason, and apparently actually it works. So we can see a technological reason why natron was used, even if this question of oil still remains quite obscure to us. But actually, other reasons as well could have somehow led the ancient alchemists to use this substance. Since we are in a phase of the ancient alchemy where basically these experts were living and working in the Greco-Egyptian, in the Greco-Roman Egypt. They were in close contact with Egyptian temples. And we know that the natron, so this white powder, was used in many rituals in ancient Egypt. And for instance, if we look at the temple of Edfu, we have recipes inscribed in the walls of the temple that describe how to make natron balls. And we know that natron was used for the embalsamation rituals and as a cleansing, basically, ingredient. So we might wonder whether the decision of trying the procedure with the natron and with natron oil could also be understood as the result of the influence of cultural, religious, and factors in the development of this special technology. But this is something that we are still exploring, and this is just a final hypothesis that with which we would like to end our joint paper. And thank you. Just a note: we know that even today soda is perceived as a cleansing ingredient. So this kind of beliefs have a very long history sometimes. So thank you very much for your attention, and we are now ready to answer questions or curiosity on the paper. Thanks again.
Well, thank you, Matteo, Lucia, and Marianna. That was a very intriguing and very rich paper. So I will now start taking questions. We have about 25 minutes, actually 35 minutes to take questions. You can raise them in the chat, or you can raise your hand. Okay, we already have one question from Alexander Roberts. I probably don't pronounce it right. If you can just briefly say who you are and where you're from, that would be also helpful. Thank you.
Great. Thank you very much for this talk. So my name's Alex Roberts. I'm at the University of Southern California, so I'm pretty far to the west here. So this is in Los Angeles, just to locate it. This very interesting talk for me. Thank you very much. I had a number of questions, but I'll just ask one, which was about the interface between how you are using these then or really a detail of how you're using these really wonderful, this very interesting set of experiments to then read back in the sources. And you mentioned at one point I think it was a Zosimus text that used, I think maybe it was a different one, sorry, that uses the word species. And perhaps this is something you can answer from your own expertise without recourse to the experiments. But I've been puzzling over this how genus and species are understood in this kind of context in the Anonymous Philosopher, another Byzantine alchemical text, for those of you who don't know it. And I had been thinking from the context and trying to make sense that somehow genus seemed to mean the metals, and then the species were the sort of byproducts of metals. But that was just a hypothesis. So I wonder, based on either other evidence or the experiments that you gave, can you say more about how you, if I understood right, you were identifying the species in that context with metals? Is that the copper or the tin or lead that were introduced?
Thank you very much, Alex, for the question. Yeah, that passage is particularly difficult, I think. So this was a first attempt to read that passage along with other passages by Zosimus in the light of the experimental data, if you want. And the use of species, of eidos, in that context is not completely clear to me, to be honest. I really like your suggestion to differentiate between genus and eidos, actually, and there is something similar also in the Christianus work. For instance, in the first chapter of the 30 chapters of Christianus, where there is a distinction between genus, or apparently there is a distinction between genus and eidos. And in that case, if we want to read the source according to the experiments, we could interpret species as any substance that was used to process cinnabar. So for sure metals, but maybe even natron oil, since it is talking about boiling cinnabar with species. And the only procedure where we actually would have some kind of boiling, if you want, is the one with the natron oil.
Right. Huh. Okay, well, thank you. That's very helpful. Thank you.
Okay, we have a question from Umberto Veronesi. Umberto, please.
Hello, can you hear me?
Yes, yes, we do.
Good. Hi. Hi, Matteo. Thank you very much for the talk, and thanks to your collaborators. It was really very, very interesting. And while I was reading through the paper and also now during the talk, I kept thinking about this thing, which is basically all of those chemical reactions that you showed are possible in a way thanks to sulfur changing companion, if you want, moving from the mercury to the other metals, and not just the metals, to the other reagents in these reactions, which is quite interesting in a way because it's sulfur. So because it's not just about mercury, but this is also about sulfur, and sulfur is the other main components of things in the sulfur mercury theory. Now I know that it's not as immediate, I imagine, the connection between the sort of sulfur that alchemists had in mind with the element sulfur, but I just kept thinking about this thing of sulfur being almost like the thing that makes it possible, the thing that moving around makes it possible to obtain mercury, and then and so on. So it was quite fascinating. Now, of course, it's not really a question. It's more like something that may be interesting to, I don't know, to think about. But I was wondering if there's any mention of this in the sources in a way. Obviously, again, not like sulfur, but like this idea of something moving and leaving mercury and attaching to something else, maybe.
Thank you. Hi, Umberto. It's a pleasure to see you, and thank you for the question. I don't know if Marianna or Lucia want to add something about the chemistry of sulfur in these reactions. Then I can say something about the role of sulfur in from a more, if you want, theoretical point of view, according to ancient alchemical theories. But
the only thing maybe we can add that we were surprised. Actually, I was surprised because at the same time they know that there is sulfur inside. That it's easy to understand that they can relate mercury with cinnabar, because you have the cinnabar, the ore, you see the liquid, but you have no idea about the vapor that are formed. There is no idea. But they have, and actually we are doing the reaction with mercury and sulfur, the native sulfur, because it was known to get cinnabar again. So that's in somehow they found out that there is a combination of the two, and they do not know anything about atoms. So that's something that is important. The other thing is that I'm thinking that a lot of sulfide metals are reacting quite easily. So also for if you want to do the extraction of iron, you start with the sulfur and the iron sulfide, and so it's somehow easy to these ores are quite easy to react. So they just, I think, I don't know how they found out how they reacted, because in some cases the temperature are very high. So it's just not a fire, but you have to have a fire with some fluxing oxygen. You just have to flux air inside to reach a temperature up to 800 degrees or 1000 degrees, but they know how to do it.
And if another interesting point, I think, in this respect is that if you read Theophrastus, for instance, he talks about how to produce mercury from cinnabar. So it's not very clear from the earliest recipes what is the relation between what is produced, let's say, mercury and cinnabar. Maybe Theophrastus was believing that he was transforming cinnabar into mercury and not, extracted something that was in cinnabar, in the ore. And this becomes very clear only in the alchemical tradition, where actually, as Lucia was mentioning, they also knew how to produce artificial cinnabar. So there are basically description I read in Zosimus of techniques that basically combined mercury and sulfur in order to produce cinnabar. So this circularity, if you want, of the procedure could be also something on the basis of the theory of the sulfur-mercury theory, I think. But this will become very clear only in the Islamic tradition, only in Balinus or Jabir for sure, or Razi.
Thank you very much.
Thank you for your comment.
Just a related question. We have several questions, but I just wanted to ask, I mean, is it a fair question? I mean, is it a fair assumption to say that the cold version was the first, and then there was the hot version, the extremely hot version, and then there was the cooler version? Is that basically a chronology that you could establish, or?
This is the chronology that basically emerges from the texts that are extant. And so the earliest is the cold reaction or the cold extraction, and then we have basically the hot extractions that are reported or recorded in texts that are almost contemporary. But it's always difficult to establish this kind of chronologies, because sometimes it's just a matter of what survived in the textual tradition. So I would be cautious in this sense, but this is exactly the chronology that we see in the sources that are still available.
Okay. John Christie from University of Oxford is next. John, you have the floor.
Oh, thanks very much, and thanks so much for such an interesting presentation. I think the whole project sounds fascinating and potentially very, very significant. What I was struck by was obviously the empirical nature of what you are doing. You have descriptions, accounts, and you try and identify the substances, the processes, and replicate, and so on and so forth. But I think I remember in some of your opening material, you indicated also an interest in theory. And I couldn't see where theory was in what was presented, in terms of a theoretical background or a sense of concepts, if you see what I mean. Are you keeping that to one side at the moment, or is there something there of a conceptual and theoretical rather than a technological and practical nature?
Thank you for this question. You're right that the theories implied or in this presentation was very, very little. But I think my reference to the theories was especially to the sulfur-mercury theory. So how the ideas on the constitution of minerals and in general of matter. And if you want, there is another aspect of the research that is not, we couldn't present today, that is about the role, the theories that explain how transmutation is possible.
Okay.
And in these theories, especially in Synesius, and then in the later tradition, Mercury is a very important, plays a very important role, because they believe that Mercury had a very peculiar nature, and they were trying to theorize this nature and to explain it in Aristotelian terms. So that's the theoretical part, at least linked to these experiments, that wasn't very, very developed in depth, let's say, in the presentation, but is there, I think.
No, I wasn't commenting critically, Matteo.
No,
I just thought it had to be there somewhere.
I didn't take your comment as a critic, absolutely not. I was just explaining, because I did mention theories, but it was just a very small part of the presentation. So thank you.
Well, that explains very well. So thank you.
Thank you, John. Well, I'm hesitating to introduce you as Campus 2020, but maybe you can introduce yourself. The next question, please.
Yes, here is Rudolf Werner Sukup from the University of Vienna, Austria. Okay, I have only a very little comment on the X-ray diffraction method for analysis. I think it's a very fine method, because we had some experience in about 1995. We could made very fine analysis in some vessels out of a laboratory from the end of the 16th century, found in Lower Austria. And perhaps something in connection with the Mercury chemistry, we could identify this calomel. It's Mercury 1 chloride. It's Hg2Cl2. It's the first time it was possible to find it in sublimation allude, as you can see one of these alludes here in the remnants of a alchemistic laboratory from the end of the 16th century with this X-ray diffraction method. I think it's a real fine method, and I think it should work in an exact way. Thank you very much for the interesting presentation of this interesting paper. Okay, this is my only comment.
Okay, thank you. I think we cannot add a lot more. The idea, actually, X-ray diffraction can be helpful in characterization also all samples. A lot has been done also for trying to understand also the technique used for the metal, how to forge the metal. And in our case, actually we are using a quite standard way. We are not, and so that's why I was surprised that no one used it to characterize this fraction. And so that means that they never tried that. It's everybody, but a lot of chemists were very, very enthusiastic about, oh yeah, I would like to do it, and they just maybe a little bit lazy and they didn't try.
4 hours grinding.
Okay, we didn't do all time 4 hours grinded. We use a ball milling, so we cheated a little.
Can I also ask about the dangers of using this? I mean, especially the cold technique. I mean, how do you do it? I mean, how do you?
We are working under a hood, so all the fumes even in the first case I show you, we had this tube where we actually were able to contain the fumes. But even in the cases where we have just the lid on the crucible and we heat up the cinnabar, we are working not in open air, but we are under the hood where we can actually, as you can see also maybe in the video, turn down this glass protection, and everything is actually filtered, and it's a normal procedure for a chemistry lab. For sure, I will not do that without this safety. But just, I mean, we are chemists, so we just reading the hazards and the security, the safety procedure, we can actually, we are able to work under perfect safety condition.
So if I can add a point, that sometimes that it's difficult to do a real replication, because in the real replication, they do not have taken into account also of the safety procedure. So that's why we have to adapt what they did for something that can be done in our lab. And just to prevent the health of Marianna. So, but I'm pretty sure that so sometimes maybe you have a distillator apparatus that it was not reported in the answer, but is we are just trying to be as close as possible, and just to check that what was written is reproducible, and that's why there's some differences.
Okay, thank you. The next question comes from Giacomo Montanari. Well, if you can briefly introduce yourself as well, thank you.
Thank you. So I am a chemist. I'm a former student of Professor Maini, actually, and hello. And I am now a student in pharmaceutical technology. Therefore, my question is a bit technical, and it's about the choice of flaxseed oil in particular for the natron oil, because when you mentioned the flaxseed oil, the first thing it came to mind, it is that is a quite low smoke point oil compared to even something like a olive oil, which is nearly twice the smoke point. So it is preferable. The flaxseed oil is less preferable when you have to heat up the oil, and that's essentially the reason why it's not really used in pharmaceutical application. Most pharmaceutical application nowadays. So I was wondering why you went for that, and if you tried other oils, and I don't know if it's maybe not historical or not really historically viable, but even a mineral oil for that application rather than a vegetable one.
Thank you, Giacomo. We have tested different oil. I just bring that one that I was taking picture of. But I think also we tried olive oil as well, because they actually add it, and it's not working as well. We don't have the problem of burnt in that case, but again, we were not able to separate the mercury. We have tried also sunflower oil.
Sunflower.
Yeah, we tested more or less what they could have experienced, but none of them. It is the only solvent that actually prevent the extraction of mercury instead of promoting. Yes.
And about the use of mineral oil, that's I'm asking to Professor Martelli about the possible historicity that I am not really sure. But if it's historical or historically possible, could be a possibility that deserve investigation, in my opinion.
Yeah, thank you. Thank you very much for the suggestion. Actually, I didn't think about mineral oils. And as far as I know, they are not explicitly mentioned in the alchemical sources, at least not in relation with the natron oil. but this is for sure a possibility that we will explore. I mean, that's because we didn't, to be honest, we didn't think about this option, and that's maybe is the key, you know, to unlock this question of what is natron oil, because natron does work actually, and but we couldn't really understand what this oil is referring to. And
but did they use actually all also for lighting? They was using only the vegetable oil.
Yeah,
so the mineral oil actually was not very common.
It wasn't, at least according to my knowledge, it wasn't common. But,
so that's why we talk about that, but we excluded because it was not referred in any paper, so it was also it was not a common ingredient also for other procedures. That's why.
Okay, thank you.
thank you.
Thank you, Giacomo. Jenny Rampling has a question. Jenny, if you can hear me.
Hi there, thanks very much, Joe. Sorry, I'm not showing camera today. Oh yes, I'm Jenny Rampling. I teach at Princeton. Wonderful presentation, guys. Thank you for sharing your latest results on this project. It's very exciting to see. I had two questions. One is about natron specifically. Matteo, am I remembering correctly? Doesn't Pseudo-Democritus use natron at some point? I wondered if there was, if you see some kind of common factors in the use of natron in ancient alchemical experiments that might perhaps shed some light on its use in mercury extraction, although I'm guessing it might actually be the use in mercury extraction that then applies to the alchemy, but you will know better than I do. And secondly, I just wanted to invite you all to maybe say something about the more philosophical aspect of recovering lost knowledge. So I was fascinated by the quotation that you gave from Berthelot, where he's clearly spotted this already, but some time ago, and then that reconstruction seems to have been lost. And I'm just very intrigued by the cycles through which this kind of knowledge is recovered from textual sources. People try it out and then it disappears again, perhaps because it doesn't promote the scientific interest of the day. Of course, what we're doing differently here perhaps is we're looking at it as a historical rather than a scientific question. But I just wondered if you could say a little bit more about that, especially the extent to which this kind of knowledge might have resurfaced at multiple periods in chemistry's history and then just kind of disappeared again, forcing us historians to constantly reinvent the wheel. Thank you.
Hi, Jenny. Thank you very much for the questions and for being here. As for natron, you are absolutely right. Natron is mentioned in other recipes by Pseudo-Democritus, and I'm trying to collect all the, let's say, the earliest, let's say, occurrences or mentions of this mineral in order to better understand also in which form they knew natron, because this natron oil is very rare in what remains of Greco-Egyptian alchemical literature. But maybe if we extend our inquiry to natron, to Kur, let's say, maybe we can collect further information that can be useful also to understand what is this natron oil. So thank you for the suggestion. And as for the philosophical point, I think at least, and then I will leave the floor to Lucia and Marianna, but I think this is a very intriguing point, actually, and a very intriguing question. And even if we look at different people who tried to replicate or an alchemical procedure, can tell us something about the kind of chemical knowledge that we're trying to recover somehow. And I got the same feeling that there are some technical knowledge that is at some point gets lost, but after a few centuries surface again. So it's not easy to follow, let's say, the development of a special technique across many centuries, because you have this impression of technological knowledge that is not always the same level, if you want. And I don't know what I'm asking, what I'm wondering about is I don't know whether this feeling is due to the way in which ancient texts were transmitted, So there is the lack of sources sometimes amplifies this feeling, or whether this is a kind of pattern, if you want, in the way in which technology or technological knowledge was transmitted. I think this is a key question also for us.
I agree.
Yeah, actually, I'm not very good in the history of science, but what we see that mechanochemistry, when Laszlo Takacs talk about the reaction, I talk about these old sources, it was focused on mechanochemistry. And it somehow is, they want to find the root of the mechanochemistry, and they found it was a very long time ago. And because still now, when that is already 20 years old, this paper, so it, for us is already old, but they want to prove that mechanochemistry works, because there's a sort of idea that everything in solution works better, but that's true. That is also life started in solution. But the idea of mechanochemistry is getting more and more important, because it's more on the idea of sustainable chemistry or green chemistry, because you are not using solvent. So to me, it somehow is also not to somehow in a point forward the mechanochemistry, but in somehow also the chemists want to find their root. So maybe they are just a little bit tired not to be just a new science, because the physicists have all very long tradition, but the chemists have the alchemy before, and the alchemy sometimes not
really recognized
is not recognized as a science. And since the chemists have always had, sometimes have a bad reputation, because we are doing doing pollution. That is not all the time true. Most of the time we are trying to clean up things. And also they want to find that there was something in the past that has some root on that. So maybe chemists are starting to work on philosophy too. Not
Thanks so much.
There was a question from Ernst Homburg, who I think left since, but I thought it might be worth, maybe he will catch it later. He was asking whether the mercury, I mean, in their view, the mercury comes from the metal. Does the mercury come from the metal and not from the cinnabar? So the cinnabar is a philosopher's stone that liberates the mercury from the metals. Similar views exist in relation to making brass from copper with the help of calamine. I don't know if you want to comment anything on that.
Yeah, absolutely, Joe. This was something that I was a bit referring to in one of the previous answers, because it's not very clear whether they believed that mercury was extracted from cinnabar or was a byproduct of cinnabar, at least according to the first descriptions that we have. And in my opinion, yes, they believed that the metals certainly played a central role in the extraction, in the coal extraction, and maybe even that the metals were somehow the element that from which mercury was extracted. They certainly, let's say, recognized that mercury very easily is somehow incorporated by the metals. And this is something that is also described in the passage by Zosimus of Panopolis that at some point I read during my part of the presentation. So the very close relationship between metals and mercury, I think, was recognized in a quite early phase of alchemy. I don't know if I did answer the question, or at least was a kind of comment on this remark.
Thank you. Alex Roberts has another question. Alex?
Yes, I had a follow-up to Jennifer Rampling's question, but I see somebody else has a question who hasn't had a chance to ask yet. So perhaps I cede the floor to him, and if there's time, I can do my follow-up if that is time.
Alex, go ahead. Just go ahead, and I'll come next. It's okay.
Okay. All right. Sounds good. Then I'll just ask very quickly. Thank you. It was just a follow-up to this idea of how historians are, so how we read that record, the historical record. I've often thought about that, how the historiography of the last 50 years, sort of what Matteo Martelli was referring to we have this sort of old, home yard. There's this very negative view, and then every time we look, we see they're actually doing things that make sense to them and even to us. And that I wonder sometimes if, do you think it makes, so I have this sort of hypothesis that a response to the same question in a way, do you see perhaps a possibility from all of this and from working hands-on with these recipes and replicating them, that perhaps a lot of the kind of the cryptic nature or the sort of confusing nature of a tradition that maybe even seems fragmented and so on, and seems sometimes incomprehensible, can be made sense of as actually similar to, say, the modern chemical tradition, except of course that's a much more compressed story in a much shorter time and much more activity, concentrated activity, but a sort of a longer version of this story in which terms change their meaning, concepts change their meaning as sort of theories and technology develops. And likewise, that we have a very technical language that, like as you see with this natron oil, a specialist needs to know what that exactly means. It's very hard to guess what a lot of these terms mean. That a lot of the incomprehensibility comes from a mix of those two, rather than a kind of intentional. I mean, of course, we know of texts that say I'm being cryptic here, but a lot of it doesn't seem to be trying to be cryptic. So I wonder if you could say something about that sort of reading of history of the record.
Thank you. I mean, this is the aim. Let's say it's a very difficult aim, because it's very difficult to disentangle this compressed tradition, as you said. And so it takes a lot of time, in my opinion, to link experiments with the text and to go the other way around, let's say. But just to give you an example that I didn't mention in the presentation, sometimes through experiments, we can also better understand the terminology. You will refer to terminology and decnamen. For instance, we have a very long list of decnamen of Mercury in a quite famous, let's say, passage by Zosimos of Panoply, preserved in Syriac. And some of these names are water of tin, water of copper, water of lead. So all these kind of waters of metals, for instance, could be better understood maybe in the light of the experiments that we performed, since metals can very quickly amalgamate with mercury. Then by heating this amalgam, basically you have again the liquid mercury. So maybe Zosimos had in mind this kind of procedures when he was using specific code names. So this might be another key if you want to unlock some technical aspects of ancient alchemical tradition, but it takes a lot of time, because I didn't, when we started the project, I didn't think that replicating a procedure was so difficult, and we had to consider so many variants and details that to my eyes, that are not a chemist, are not evident when I read a text, of course.
Well, I'm grateful that you're undertaking this.
We all are. Well, if you're okay to take also Sean Michael's question, we started just a few minutes after, so if it's okay. Sean, if you can ask.
Thank you. Yeah, thanks so much. So Matteo, I'm sorry to end on a technical question, but this is how it is. So you know how you talk about natron oil, right? Which is basically going to be soap, right? Like whatever this is, if it's an oil. And so the question is, like you make these like hypotheses about like natron being sodium carbonate, decahydrate. And you know, from your own work in your team, like working on vitriols, you know, different kinds of carbonates, that at that period of time, like they didn't even really distinguish, like Razi distinguishes between blue and green carbonate or vitriols, between sulfur and between iron carbonates or sulfates, sorry. And you guys are working with a kind of similar type of mineral, right? Which might not just be characterized that well. So we know that there's a kind of natron oil that was used in Egypt as a kind of soap kind of thing for cleansing. But there's also different types of oils, right? Like vitriol oil isn't an oil at all, but just concentrated sulfuric acid. So I'm just wondering again, like about the main problem about the terminology, like what justifies kind of like jumping in with sodium carbonate in this case, instead of kind of like just kind of testing like a whole bunch of different metal carbonates, or even just testing stuff from a dried lake bed from the area that might be kind of closer to what they were working with.
Yeah, thank you, Sean, and hi. And yeah, you're right. It's we tried with a kind of standard identification, that because for natron, I mean, we have, as you know, we do have descriptions of natron in a pharmacological text, for instance, in Dioscorides, in Pliny Elder, even in Galen. So we do have information that can basically somehow confirm that natron was this combination of carbonate and bicarbonate of sodium, and that it was basically extracted in this region, in this Wadi al-Natrum, what is called now Wadi al-Natrum in Egypt. So we tried with this ingredient, because at least as for vitriols, we don't have, of course, vitriols in ancient alchemical vocabulary. This is something a bit that is later, but we do have in Greek misu, sori, calcanthos, that are all terms used to refer to minerals, let's say of copper minerals, let's say. But I think there is no real overlapping between, let's say, sodium carbonate and carbonate of other metals in this sense. And of course, what you were referring to, the natron soap that was used in Egypt, and this would be a very interesting hypothesis to be tested, I think. Do you know what it is? What's the composition of this natron?
Well, I just think, I mean, normally, right, like the way that if you usually would take some kind of usually would take like a kind of sodium hydroxide. So you take like a slaked lime, right? And you would use this as a way of mixing it with an oil to make a soap, like a primitive soap. And you might have something similar. Like, that's what I'm just wondering, like, why, like, are there not other compounds that might do something with an oil that might have been useful? So I'm just thinking, if we have a kind of, like lots of a mixture of different like carbonates and hydroxides and things like this in a kind of dried lake bed, and then we mix that with an oil, then we get a soap. And sure, the sodium carbonate and bicarbonate will stick around, but you also get other reactants in there that would make the natron oil a useful product to have around.
We actually tested calcium carbonate. It's not working. And also we have talked about the sodium hydroxide, and we came out at one point that was not known. But actually, if you prepare a saturated solution of sodium carbonate in water, it is actually really, let's say, oily. Yeah, it has and that's why we actually then stick with sodium carbonate. But we also have tested calcium oxide, and it's working, but they call it in a different way. So it was difficult actually to believe that they could have referred to calcium oxide as natron. And what's more, we have tested something else.
Okay, so if we want just a comment on that for the calcium oxide, because if you use natron with water, it works. Maybe it works not so good, but it works. While if you use calcium oxide that is quicklime, and you keep the idea to use in a solvent, so to put in water, when you use the quicklime in water, you get lime. So there's a problem, and the lime doesn't work.
Doesn't work in this
So that's another point that we were discussing. We don't know that they do not refer about that because they wanted to use something that have to be liquid or just or oily, so they need a solvent. And in this case, the reaction that occurs from quick lime to get lime, they just cancel the product, or they didn't try, or so there is some points that there is not clear.
That's fantastic. No, thanks a lot. And also like just the phenomenology of like putting natron in solution on your skin, right? Because it'll dissolve the skin, it will feel slimy. So that's beautiful. I really like this. Thanks.
Yeah. So that's why we tried that. We tried, that's the idea, to find everything that it can be oily. And so that's why we saw that maybe with water is not too bad.
Yeah.
Thanks a lot.
Thank you.
I'm mindful of the time. Of course, the clock in Bologna seems to be slower, actually faster than mine. It's a bit faster, but I was just wondering if you can just say a few words at the end about your collaboration. I mean, how did it work? I mean, will you do it again? Well, I mean, confess everything in front of the camera now. I mean, what are your feelings about the, future cooperations between chemists and historians of science? I mean, just from your experience.
I mean, for me, it's a fantastic experience. So I really hope to keep on this collaboration. We are still working together in the framework of the Alchemist project. But the idea, I think that at least for an historian, having this exchange with the chemist is really critical to get a better understanding of ancient sources. But I leave it. Maybe they had a different feelings.
I have been working on photochemistry before I started working with this project. And when I started actually doing this ancient chemist, for me it was like I was never doing chemistry, real chemistry, you know, like melting lead, and then, I mean, really something that you usually as a chemist read on books, and then you are the chance to actually practice. So that was really, really good, and I hope we can continue in replication.
Yeah. What I have to say that is really challenging. It's like, because it's true that we are chemists, but what we found out that you have to be a chemist, a geologist, a metallurgist, and so it's really challenging to know all about that. So it's still, I'm using X-ray powder diffraction for my work, but I'm using for a totally different organic compound, and inorganic minerals are somehow different to handle. So it's not easy. It's not easy, but I have a lot of fun. I hope this collaboration will keep forever. And in, just thinking also about as a chemist, thinking about our history. I think that's important, because we are sometimes so focused on finding something new application, new material, and that's fantastic. I don't want to say that we do not have to do that. That's fantastic. But maybe we have so long tradition that can be better than the physics. We have a little bit battle, struggle between chemists and physics.
Well, thank you so much. I mean, this was a very interesting presentation, and you three make a very good team. So it's
there are many of us.
Yeah, but it's I'm sure you're having fun over there. Everyone probably is jealous to hear about it. But most of us are historians, but we certainly appreciate chemists joining and participating in this, because of course we don't have the tools to completely understand what's going on. So, working together is certainly fantastic. So Yeah, so thank you so much. You know, it was a pleasure. Next time we will have a bit of a challenge. We'll have several speakers in a round table discussing the female presence in alchemy. So if you can join me for that, that would be fun. Matteo will be back, I hope, for that. I want to say that I'm sorry there were some glitches to the YouTube at the beginning, but I'll do my best to fix it. So, but yeah, again, it was a great session, and keep us updated to your findings. And yeah, enjoy the rest of the month and Christmas. So, all right. Well, all right. Take care then, and thank you everyone for coming. So, thank you.
Thank you, Joe. Bye bye.
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 Thank
Bye.
you.
Thank you.